Hey there, welcome to another video on math problem solving. This is Bharat Divyang from Zubzwang Academy, and today's problem is from a recently concluded Math Olympiad competition in Seattle. It's the UDub Math Olympiad competition for high school students. It starts from grade 6, goes all the way till grade 10, I think middle and high school students. And it's a very different kind of Olympiad problem competition because they ask you the questions and you get to actually explain your ideas and your solution to judges, and then based on that you'd be marked whether you got it right or wrong and then ranked later. So typically the competition's format is that you get 5 questions, and if you solve a certain number of them, then they give you 2 extra questions as well, and my guess is the person who wins typically solves all 7 of them. Now this is problem number 1 in the junior section, as in grade 6 and 7. So it's not a very complicated problem. It's fairly simple, but it allows you to start thinking logically and see how you can bring about your thoughts to help you solve and prove mathematical concepts. So let's read this question. There are 11 people standing in a line. The order of the line got mixed up a bit, but each person ended up within one spot of their original position. For example, the person who started on 6th position ended up on either 5th, 6th, or 7th. Show that at least one person ends up in their original position. Okay, so to solve this, I think I'll give you a moment to really catch this, understand this, and give it a shot. Try and prove it yourself if you could. Always, I support students who would like to really give it a shot, even though they don't know much about it, don't know how to solve it. But that's where fluid intelligence really builds. Okay. Having said that, let's come back to the problem, and here's the solution to it. If you tried it, welcome back, and I hope you got it. And all right, so let's read the question again. 11 people in a line. There is an order already, which means everybody identifies with a particular position, and now they have been scrambled up. Everyone is either in their own position or one to the left or one to the right. We need to prove that at least one person ends up in the original position. Now, in many such cases where the proof asks you to do something like this, you got to assume the opposite. In a sense, if you can prove, like you're going to prove the negative, if you can prove nobody ends up in their position and everybody has found a place in some other position, then this would be wrong, right? And if you can't prove that nobody has ended up in their own position, then you have to assume that at least one of them has ended up. So it's like logic, right? You say if at least one person ends up, it basically means that you can actually prove nobody ends up in their ends up in a different position than their original position, and therefore at least one of them needs to be here. So how do you go about doing it? And this is where my definition of intelligence will really come in handy. It's about differentiating and discriminating, knowing the difference between similarities and similarities between differences. So let's look at this. Let's write down the positions. So we have 1, we have 2, we have 3, we have 4, 5, 6, we have 7, 8, 9, 10, and 11. Now, they all are positions, yes. That's the similarity. Every one of them is a position. But let's find the difference between them. Let's categorize them. For example, the extremes are very interesting, because they're different from everything that's in between them, because the position number 1 doesn't have anybody before them, and position number 11 doesn't have anybody after them. So there's no right for the 11 and there's no left for the position number 1. So that's an interesting thing, because if you think about somebody being in the ith position, then after the scramble, they either end up being in the same place, being 1 before, that's I minus 1, or being 1 after, which is I plus 1. This is the behavior for anybody from 2 till 10. But for 1 and 11, it's different. In fact, it will be different in the sense that for 1, it would be I or I plus 1, and for 11, it would be I minus 1 or I. So not only are 1 and 11 different, and 1 and 11 in between the two of them are different. Right? They're similar in terms that they're extremes, but they're different in terms of what is the space that they have. So let's talk about the person who was originally here. Like this is an original order. Let's use a different color. This is the original order. And there was a person who was standing in the first one. Okay, and this is the new order. Where does he end up? Now we know for a fact that he ends up either in his own position or the next position. Now if he ends up in his own position, then you have already proved this. You have said that, hey, he ends up in his original position. So there's no big difference there. Which means that's not what you want to prove. You want to say that, no, he does not end up in his own position. So we are proving the negative of it. He ends up here. So he comes to position number 2. What was previously 1 has come here. So this is person 1 who has come here, right? Now the question to you is, who comes to the original position 1? Who can come here? It can't be 3, 4, 5, 6, 7, 8, 9, 10, 11. So it has to be 2. So this has to be filled with 2. This is the only way you can ensure that this entire thing works, because this is the only way you can ensure 1 and 2 both don't end up in their position. Now what that does is, if you think about it, it cuts the entire line by 2 positions down. So what was 11 position thing has now become a 9 position line. And the same story continues, because where does Mr. 3 go? He could not go to 2 because 2 is already taken by 1. So his only option left is 4. And therefore, where does Mr. 4 go? He ends up coming to 3. So this is 4 and this is 3. So this means we could keep doing this in terms of pairs of 2. And you'll realize that finally there's no space left for Mr. 11 excepting being in his own position. And therefore, you can prove that at least one person, in this case 11, is going to end up in his own position. This is after trying to see that not a single person so far has been doing it. You're going from left to right. Now you could apply the same process and go from right to left. You can say 10 and 11 first, 9 and 8 then, and you keep doing it and you'll end up with 1 being in his own position. So now you can actually see a pattern here. Now this particular thing would be very different if you had an even number of positions in the line. Because if you had an even number of positions, you could just keep swapping them 2 at a time. 1 would go to 2 and 2 would go to 1, 3 would go to 4 and 4 would go to 3. And by the end of it, you would have everybody swapped out and nobody would be there in their own position, but they still follow the rules of being within one spot of their original position. But whenever it is odd, it doesn't matter whether it's 11, 1,000,001 or 1,000,011. You would still end up leaving one person who would definitely be in his original position. Now, should it always be 11? The answer is no. For example, you could start from left and you could say 1 and 2 swap. So 2 comes here, 1 comes here. But instead of going to 3 to 4, you could start from 11 and 10. And you could say 11 swaps and 10 swaps. This is a different algorithm. And then you can say 3 and 4 swaps. So this is 4, this is 3. And then you could swap 8 and 9. So 8, 9 comes here and 8 comes here. Right? And then you could swap 5 and 6. Right? So this is 1, 2, 3, 4, 5, 6. So 6 comes here and 5 comes here. Right? And you would still be left with one person, 7, who has to be in his own position. Right? Depending on how you're going to be choosing, you'll always end up with one person, no matter what, who would be in his own position. I hope you liked the proof. I know it's more logical than mathematical per se, and I'm sure that there is a mathematical way to kind of explain it using the I's and the N's, but first figure out the logic, first figure out how to logically reason your way to a solution, think about that, and once you have it, then you can probably think about the mathematical proof behind it. I hope you liked this video and enjoyed it. If so, please do like, share, and subscribe, and I'll see you in the next one. Thank you so much.